talk about the advanced structure equation modeling, and this is the part 2 video about this. Will talk about the measurement model comparison. A key definition of achieving construct validity is that a construct will meet of the requirement of reliability and the validity not only in one situation but hopefully across all of the potential situations in which it can be applied. Although rigorously testing in the development stage, many support construct validity. Researchers have long been aware of need to research a construct, particularly when comparisons are made within the same study. Increased application of structure equation modeling, cross-cultural studies, long, longitudinal studies, assessment of differences based on the personal differences, for example, gender, and even context, that is, the type of workplace or setting, have brought to our attention the need for a formalized process of making group proper comparison. Today we see measurement model comparison in two related areas. The first is broadly known as measurement invariance of measurement equivalence. The primary objective is to ensure that measurement model conduct and different condition yield equivalent presentation of the same construct. As we have discussed, the type of situation using the approach has become quite extensive. Yet, even with the increased awareness and availability of the structure equation modeling programs, in many areas of the research that required measurement invariance, that is cross cultural research, it is still infrequently used. Specify instance of the measurement model comparison is a cross validation, the attempt to reduce the result found in one sample using data from a different sample. Generally, cross validation used to sample drawn from the same population. In other words, the sampling in each group would have the same characteristic. Perhaps the most basic application is revoiding a second confirmation of the measurement theory that survived initial testing. One way of the completing this task is to split a large sample randomly into the two groups so that each sample met the minimum size requirement discussed earlier. A six-step process of group comparison. What both of these areas have in common in their joint use of what have been known as multiple confirmatory factor analysis. Confirmatory factor analysis provides the basic for establishing construct validity through the measurement model. MCFA now extended CFA into the multiple group situation where separate samples are collected for each group and then comparison made to determine the variance or equivalence as might be expected. Numerous aspects of the CFA model are available for comparison. Recent research has converged to identify a systematic framework for evaluating all of these aspects in the progressively more rigorously set of the comparison that address the most elemental aspect in the earlier stage. The foundation of the process is a series of empirical comparison of model with increasingly restrictive constraints. The fundamental measures of differences used in the chi-square differences. These measures allow for an overall comparison between two model specification, that is one without constraint. The basic logic is that if a set of constraint is applied and the model fit as measured by chi-square does not show a significant increase, meaning worst fit from a less constrained model, then the constraint can be accepted. General practice is the start with the most unconstrained model, that is the separate and unique confirmatory factor model is established for the each group. The between group constraints are added to reflect specify measurement model comparison. A between group constraint establish a single parameter for the relationship rather than the estimating a unique parameter for each group. Those it represent the hypothesis that the relationship being tested is invariant equal across the group. If imposing this constraint does not significantly increase model fit, then it can be accepted and the researcher can assume invariance for the relationship in the measurement model. One feature of the measurement confirmatory factor approach is that although basic measurement of fit are provided for each group model, all of the model fit measurement are provided for the collective set of the group models. So in simple terms, the chi-square for all of the group models are added together, and measurements such as confirmatory factor analysis and RMFEA and the other calculation for entire set. In this way, comparison can made on model fit measurement across MCFA model confirmatory factor analysis model with differing set of the construct. Although all model fields indicate are available for the set of the group, the primarily measurement used for the comparison is the chi-square differences, because it can assess with the statistical significance level the degree of freedom for any model comparison or number of the parameter estimates constraints that are added from one stage to another. For example, assume that we have three groups. Before any comparison is made, we would separate model for each group means their unique loading estimated for each variable in each group. Now assume that the loading estimated are assumed to be equal. Instead of three estimates, we would have only one estimate that is best estimate for the three groups combined. Now we would have two less loading of the statement for each variable. So in general, the numerical degree of the freedom differences test is equal to the number of equality construct multiplied by one less than the number of group. This will determine the degree of freedom used to test the significance of the each test. We will first describe the 6 stages in terms of both measurement model, issues they address, as well as the nature of the construct used. It is important to note that at each stages a new set of the construct is added, one to those in the previous model. For example, the model at the stage 3 will have all of the construct imposed in the stage 2 plus those added in the stage 3. So the chi-square differences test can be made between the model each stage rather than the initial of the baseline model. It should also be noted that there are various levels of passing the test at each step of those we'll address in the following section. Number 1, stage 1, we call it the configural invariance. In stage 1, the first stage confirmed configural invariance, that the same basic factor structure exists in all of the group. Researchers should confirm that each group confirmatory factor analysis model has the same number of construct and it's associated with each construct. Moreover, it must be shown that each group model needs inappropriate level of the model fit and construct validity. The measurement theory terms, we are now ensuring that the construct are cognatic across the group. This model is sometimes referred to as the totally free multiple group model, because all of the free parameters are established separately and therefore free to take on different values in each group. The TF model also become the baseline model for comparison. Stage 2, metric invariance. The second stage provides the first empirical comparison between the MCFA model group and involve the equivalent of the factor loading. Metrics invariance establish the equivalence of the basic meaning of the construct because of the loading denote the relationship between the indicators and the latent construct. This is the critical test of the invariance, and the degree to which this is the determines across the validity beyond the basic factor structure construct are the set so that the factor loading are equal across the group. LX1 group, these are the groups, and note that while the loading of x1 are equal to across the group, each measured variable has its own unique loading estimate. It is computed between this model and the TF model with the degree for freedom equal the number of the construct loading estimated across the groups. In stage 3, that is the scalar invariance, the third stage is scalar invariance, which tests for the equality of the measurement variable intercept, that is means on the construct support to the scale invariance in the required if any comparison of the level. For example, mean store are made across the group. Scalar invariance allows the relative amounts of the latent construct to the compared between the groups. Stage 4, factor covariance invariance. In the fourth stage, the covariance between the construct are constrained. Factor covariance invariance test if constructs are related to each other in a smaller fashion across the group. Note that in this stage, the degree of the freedom come from the constraining for the factor covariance rather the loading for each measurement variable. Stage 5, factor variance invariance. Now the test is for factor variance invariance, which assess the quality of the variance of the construct across the group. If factor variance and the covariance are equivalent across the group, then the latent construct correlation also are equal. In stage 4, that is the error variance invariance, the final stage test for the error term covariance for the each measurement variable across the group. This test is for the amount of measurement error present in the indicator of the extent of the which it is equivalent across the model. Full versus partial invariance. The chi-square differences test we described earlier is a test for the full invariance, meaning that constraining all the parameters relative to that type of the invariance to be the same in each group does not significantly worst fit. In this case of the metric invariance, this would mean constraining each corresponding loading to be the same in the each group. Yet fully invariance become more difficult to achieve as model because complex at the test progress of later stage. Partial invariance, a less conservative standard involving at least multiple estimated per construct to the equivalent across group. A general consensus has developed at if two parameter per constructing metric invariance intercept in a scalar invariance, even error terms in error variance are found to be invariance, then partially invariance is formed and the process can extend to the next stage. If fully invariance is not supported, researcher can systematically free the constraint on the each factor that have the greatest differences in the hope that the delta x square will become the non-significant with the least two comparison per construct. One approach to identify the constraint that should be eliminated first is to examine the demodification indices for the fully constrained model. Remember that modification indices suggest the change in x square associated with estimating a relationship, thus the equality constraint with the largest modification index should be the free first. An approach using the specification research feature of structure equation modeling program to identify and the free the most destructive constraint has also been proposed. No matter what approach is taken, the objective is to free and the few constraints as possible to achieve invariance. What level of invariance is needed? With the 6 stages and the level of the invariance now defined, the final question is what level of the invariance is needed? It is necessary to achieve at least partial invariance for the all stages. The answer to that the question depend on the type of research question being addressed, but for the most research questions involved with the comparison construct means across the group, achieving the partial scale invariance is sufficient. Matrix invariance is relevant in establishing among the construct which is more likely needed in the testing structure relationship differences such as the test of the moderation. Moreover, it has been found that error variance invariance is merely achieved and only the necessary to demonstrate equal construct reliability across the group. Table 2 provides the guideline for the level of the invariance needed for different type of the research question. Focusing on the measurement model issues, we can see that the most common issues: equivalence of the basic structure of the construct required configural only a test whether the construct related to the indicator in the same way require partial matrix invariance, that is the last two loading per construct must be invariance only when the comparison of the latent construct mean are made scarce invariance required, not that the although fully invariance is always a stronger support of the type of the construct being the tested partial invariance. This is the table suggested minimum level of the invariance by the research question. This is the measurement model comparison and structure model comparison. Level of invariance: basic structure is the construct perceived and used in a similar manner. Mean level: do the groups have equal amount of the latent construct? Structure equation modeling: the theoretical relationship equivalent, it is the relationship between the construct the same across the group, and theoretical relationship equivalents are correlations or standardized loading the same across the group. Configural matrix scalar factor: full partial, partial, fully partial. These are the partial and the full. Measurement model, the level of invariance, so it's a full the configural and remaining matrix scalar are the partials. Minimum level of the invariance required any of the stage except configural invariance is a practice standards that is acceptable particularly as a model become are more complex. HBAT invariance analysis: during the course of the interview between the HBAT management and the consultant, numerous issues more suggesting need to compare full-time versus part-time employees. The concern was that just taking the normal perspective on the employees might overlook noticeable differences between these two groups. If was felt that the first step should be the make sure that these groups are hand common perception about the workplace attitude that hurt consider important in their employees effort. This lead to be called for empirical comparison of the two groups on the 5 construct and employees relationship rational model. Group were formed the respondent to the HBAT employee surely based on work status, fully time or part time. In this case, the group were of the almost equal size: 191 part time employees, 209 full time employees, and with a group of their respondent defined the invariance testing the process of the game. 6 stages of invariance testing process. The group model were specified based on the 6 stages. I had earlier mentioned about the 6 stages. Here we see the stages in a practical ways. Process and then the estimated table 3 contain the model fit statistical for each model and the measurement testing for the full time versus the part time employees. The model test is separate x square and dr. These are the result. Chi-square differences test for each model comparison in the first stage. Configural invariance, the separate model for full-time and part-time employees both exhibit acceptable level of the model fit. It does the combined MCFA model. Note that the MCFA x square is equal to the sum of the employees and group of the model and other fit. Significantly acceptable fit across the two groups, indicating configural invariance. The next test is the matrix invariance and involving constraining each of matrix loading to the equal across the group. We can see that the x square is only 12.7 with 16 degree of the freedom, which is indicates of the non-significant differences that 16 degrees of the freedom represent the 16 free factor loading that were constrained to be equal to the other group. Remember that one parameter are constrained to 1.0 the set the scale of each construct those the living 16 free parameter across the measurement variable. Those the two model exhibit fully matrix invariance. The next stage is to test for scalar invariance. Here the x square is the 71.0 where the 21 degree of the freedom. This differences is statistically significant, indicated that the full scalar variance is not supported for the illustrative purpose We will continue to the next stage of the process and then return to the assess if al- at least partial scalar invariance can be achieved. The next stage test for the factor covariance and the x square of the 13.810 degrees of the freedom is non-significant. From the result we can support invariance in the covariance among the matching construct. The next test for the factor variance shows very little differences for this construct, indicating that the factor variance are almost identical between the two models. For first invariance test for the unequal and error terms indicated, as expected these tests has significant chi-square differences. Is x square is equal to 51.5, df is equal to 21. It If this would have been supported, then equal reliabilities would have been for construct in each group. We now return to see it we can achieve at least partial scale invariance. Modification indices for the scalar invariance and model were examined to identify the construct of the item. Intercept what could be freed to most reduce the chi-square differences. As a result, 10 items, 2 per construct, were identified to retain their construct in the test partial scalar invariance. This item were GS2 square, GS4 OC, OC4 SI, and these are the EP2 and EP, a model construct constraining each of these parameters to be equal to another in each group's product, and delta x square of only 6.6, df is equal to 10 from the matrix invariance model, which was not significant. Those the partial scalar invariance can be supported as well. Those comparison between the construct mean are possible. Let's talk about the measurement invariance conclusions. The measurement invariance testing process demonstrated that the 5 constructs used in the employees retention model met the criteria for the configural invariance, fully matrix and the partial scalar invariance. As a result, most any from the group comparison can be done without the concert of the differences that are due to differentiating measurement properties between the two groups. Structure model comparison. I'll talk about the structure model comparison for the next video.